Hi, my name is Dima, and today I'm going to talk about C++ core guidelines on concurrency. So why to use concurrency? In general, there are two reasons to use it. The first one is separation of concerns, which means the classic example of GUI thread and working threads. And the second one is using concurrency for performance, which means task parallelism. Divide task into several threads, and the second one is data parallelism, which means performing the same operation on different kinds of data, let's say different kinds of files or something like that. So the first guideline I want to discuss is CP1. Assume that your code will run as part of a multi-threaded environment. So the idea is sometimes we don't know if concurrency is used now or will be used in the future, and code gets reused and libraries are used from different parts of the application, so sometimes it happens. Let's take a look at this function, cached computations. It seems that it works perfectly in single-threaded environment, but in multi-threaded environment, these two static variables, cached x and cached result, may lead in data races, they will definitely lead to data races. So the ways to fix the issue are the following. Delegate concurrency concerns upwards to the caller, which means to lock them on the caller side. Make the static variables as thread local, which might decrease the caching, the efficiency of the caching. And you may implement concurrency control, for example, to add some static mutex inside the function, which might reduce the performance, and you may refuse build or run inside the multi-threaded environment with keys or compilation keys or something like that. Or you may provide two implementations, for example, with the template parameter as a policy, the one for single-threaded environment and another one for the multi-threaded environment. So next one is CP22. I'm jumping because there are a lot of guidelines and I'm trying to be short. You may find a lot of them at the official website, so you're invited to take a look at them. So CP22, never call unknown code while holding a lock, for example, a callback. Sometimes you don't know what the code does. For example, if you have the observable class, which is in its function change, it updates all the observers when its state changes, and pass, for example, pointer to itself there. So you might have a lot of types of observers, and some of them may change the state of observable, which can lead to a deadlock. So the solution is simply to use the recursive block, the recursive mutex. Maybe it can be a little bit more expensive than a regular one, but it's definitely much cheaper than deadlock. So CP25, prefer using GSL joining thread over std thread. The idea is that when you create std thread, you may explicitly tell what you want to do with it at the end of the scope, or join, whether you want to join or detach. Otherwise, std terminate is called, which will bring your application down. So if you want to avoid this situation and don't care about this, you may use GSL joining thread, which joins automatically at the end of its scope. So as simple as is. Currently, GSL joining thread is in a pull request at GSL library, but you have something like that in Boost. It's called, if I'm not mistaken, scope thread or something like that. Actually, it's an implementation, something very similar to what Anthony Williams has wrote in his book on concurrency in C++. And last, CP26, don't detach a thread. Basically, we do this when we want some thread to run forever until the end of the life of the application, that is doing some background tasks, monitoring something, or something like that. But the problem is that if the thread function exits, you have no option to know it. You don't have a handle to the thread, so like, and it can lead to problems for your application. So there are two kinds of solutions. The first one is to create your thread, joining thread, and outside of the scope of creation. Let's say you may start it in the main function and join at the end. In any case, you want to run it in the background. And the second one, if you want to separate point of creation from the point of ownership, you might create it like usual joining thread in a unique pointer and run it and pass the unique pointer to someone who wants to hold it. In this way, the function heartbeat is going to run until TikTok is alive. So basically, that's it. The last thing I want to discuss is the alternatives to the concurrency, because concurrency is a rather complex thing. It's locks and sharing data. So if you're doing a lot of parallel tasks, you may consider using libraries and frameworks providing higher level of abstraction, like Intel thread building blocks, Microsoft Parallel Patterns library, or OpenMP. You may think of threads or even separate processes communicating via IPC message queues like 0MQ, file system events, or sockets. And you may take a look at libdeal and libme libraries that are implementing those style concurrency in C. I think they're worth looking at. So that's it. Any questions? Thank you for listening.